Hey, what's going on, guys? Let's look at this problem right here. Here we have a first order differential equation. We know this is a first order by looking at the derivative. If it's first derivative, it's a first order, and also the y power shouldn't be above 1. If it's above 1, it's not linear. Okay, now this is already in standard form, because the standard form of the linear first order differential equation should look like this. We have to have dy by dx, that's y prime, and that one plus we have to have a function of x multiplied by y, that should be equal to function of x. Okay, now in the other side we don't have any function of x. In this case we assume we have a x power 0, right? So this is even if it's a number, it's still a first order linear differential equation. Now first thing is we have to find out the integrating factor. First we have to make sure this is in standard form. In order to be in standard form, the value in front of dy by dx should be 1. Like there shouldn't be anything multiply this one. If something is multiplying, we have to divide by that one. We have to divide everything by that in order to get rid of that coefficient. But here we don't have anything, so we can directly go ahead and find out the integrating factor. To find out the integrating factor, we use this equation. Mu is equal to e power integral p of x dx. Now p of x is the value that is multiplying this y. This is the p of x. Now if you look at this one, here we have y. This tan x is multiplying, but you have to make sure you notice this sign also. If the sign is negative, we have to include that negative also, because in standard form it should be positive. Here we have a negative. It means negative tan x is the p of x. P of x is equal to negative tan x. Now we have to find out the integrating factor using this p of x. Now let's do the integration alone, this part alone first, then plug it in e. Now to find this one, I'm going to p of x is equal to integration of p of x dx. That's equal to integration of negative tan x dx. If you integrate negative tan x, that's going to give you absolute value of ln cos of x, cos x. How did we get this one? You can think it like, let me write this one separately. Like integral of tan x can be written as negative sin x over cos x, okay, dx. In that way we got this one, like ln of cos x absolute value. Now we have found out this one. The next thing is we have to plug it in this equation to find out the integrating factor, because we only dealt with the top part, right, e power part. Now we have to put it in e power. Mu is equal to e power this one, ln cos of x, ln cos x, and that's it. Now e and ln cancels each other, and we will get cos x, but we don't have to worry about this cos x, I mean absolute value, because when you multiply, because after we find out the integrating factor, we are going to multiply both sides. If you think about this, if we have, because if it's absolute value, we will have positive negative, right? Positive negative. If it's negative, what's going to happen? We will have multiplied negative both sides. But since we have negative both sides, the negative will cancel anyway. So we don't have to worry about this absolute value. It's always, if we have absolute value, we can just get rid of them and multiply by the positive value. Now when we multiply cos x both sides, that's going to result in y prime cos x minus y tan x cos x, and then in the other side we have 1 multiplied by cos x, that's going to be just cos x. Now the next thing is, after we multiply by the integrating factor in linear first order differential equation, this value, this y prime cos x is always equal to, if you find the derivative, this y prime, we can also write this one as dy over dx. So let me write this in that way so we can see it clearly. I move this y here, and dx, if you take the derivative of this one, you will get this back, because that's going to be a chain rule, and you will get this one back. You can try this one and you will get this one back. This is always true for linear first order differential equation. After you multiply by the integrating factor, this value will be equal to other side. It's always true. Okay, now we can go ahead and equalize this one to cos x. After that, we have to integrate both sides with respect to x. With respect to x, if we integrate this one here, integration and derivative cancels each other, so we will get y cos x. In the other side, if you integrate cos x, that's gonna give you sin x plus constant. Okay, and the next thing is we have to write everything in terms of y. So in order to get rid of this cos x, we have to divide everything by cos x. If you divide sin x by cos x, that's going to be tan x, and plus c over cos x, that's going to be tan x. Instead of c over cos x, we can write c sec x, not sex, sec x. Okay, and that's going to be the general solution of this differential equation. I hope this helps. Thanks for watching. See you next time.